Okay, in this video today, we're going to talk about a concept called power. But first, we're going to review back over the things we've already covered in Unit 5. First thing we covered was something called work. And we define work with an equation where work is equal to force times distance. All right, and then if there's an angle, we'd add a cosine of theta to that. But that's our general equation right there. Now, if something is being lifted against gravity, our equation for work changes a little bit, and we get mgh, where m times g, remember, is the force of gravity or the weight of something, is that m times g. So we have to be very careful when we work these problems with work, because if we're given a weight we're given a mass, say in kilograms, say something's 10 kilograms, then we would want to use this equation right here to calculate the work. But if we were given something like 20 newtons, something's weight is being picked up, well, that 20 newtons is F of G, force of gravity, and that's equal to M times G. So we just take 20 and multiply it by the half. There's no point in dividing it by 9.8 to come up with a mass, but then multiplying by 9.8 again, and then by your half. So you have to be very careful. If you're given a mass in kilograms, use mgh. If you're given a weight in newtons, you'd want to use this F times D, distance, which is the same thing. Usually we use this one if we're talking about something moving horizontally, a force over a distance, and then we use mgh if something's moving vertically. However, those equations can be used interchangeably, just depends on what you're given. Now, also we talked about potential energy. It is stored energy, and we use the same equation, mgh, to solve for it. So pretty much work is equal to energy, or the change in energy. We can use the same equation for that, where m is your mass, g is 9.8 always, h is your height. And then we have kinetic energy, which is energy of motion, and our equation for that is 1/2 mv squared, and where m is your mass in kilograms, v is your velocity in meters per second, is what you would need that. All right, and those are the three things we have talked about so far. And the fourth concept in this unit is something called power. Now, we can define power as the rate of doing work. All right, so if it deals with a rate, we know there's a time aspect to it. And it's measured in, the units are, for work, the units are joules. For energy, it's joules, because work energy is about the same thing. And then power is joules per second, or what we call watts. And we abbreviate that with a capital W. But just remember that, 1 joule per second, and I would write this down, 1 joule per second is equal to 1 watt. It's the same unit. Now our equation we're going to use for power, we use P for power, and that's equal to work divided by time. Now, we know that in our problems, it's not going to be as easy. We're not always going to be given work. We might be given some other things to solve. So we can also, since work is equal to mgh, also we can plug that in. So power, could be equal to mgh divided by t. And also, work is equal to force times distance. So another form of that equation you could use is power is equal to force times distance divided by time. So you'll need all three of those equations right there to work these problems. Okay, our first example says Lover's Leap is a 122-meter vertical climb. The record time is 4 minutes 25 seconds, was achieved by Dan Osman. And this is his weight or his mass. What was his average power output during the climb? So I'm going to go through the problem and underline what might be important. I'm given a distance, I'm given a time, and I'm given his mass. So what's his power output? Well, power is equal to work divided by time. I'm not given work, but I'm given some other things that I can use. I'm given what I would want to use, since I'm given a mass, I want to use MGH in there for work divided by time. And I'll plug my numbers in. My mass is 65, and G would be 9.8 times my height, which is 122. Now that by my time, what's important in my time is in seconds. I can't have it in minutes or hours. So I'll need to change 4 minutes, 25 seconds to total seconds. So 4 minutes would be, 4 times 60, which would be 240. Yeah, 240 plus 25 more, which would be 265. All right, so I plug that in. I take 65 times 9.8, and then multiply that by 122. That equals 77,714. Then I want to divide that by 265, and I get 293.3. And my units will be watts. So my next problem says a 1,000-kilogram car does 5,000 joules of work in 4 seconds. Calculate the power output. Well, I know, it's giving me a mass, it's giving me the amount of work, and it's giving me 4 seconds. And calculate the power. I know power is equal to work divided by time. And I'm given work. I'm given 5,000 joules of work. I'm given time. This 1,000 kilograms doesn't matter in this problem. I just want to plug in my work, which that would be 5,000 divided by my time, which would be 4.00. And that equals 1,250. And that would be watts. Okay, another useful formula. There is another formula we can use, and pretty much the formula, another useful formula, and don't worry about this part here. Another one is power is equal to force times velocity, where P is is equal to force in newtons. And then V would be velocity in meters per second. Now, the only problem is you can only use this if something's moving at constant velocity. That's the catch. So my question here says a student uses 140 newtons to push a block up a ramp at a constant velocity of 2.2 meters per second. I notice I'm given a force in there and I'm given a velocity. So I've used my equation P equals F times V. So power would equal to 140 times 2.2. And when I get my answer, it would be 308 watts. Now, this formula is only useful when velocity is constant. Okay, my next problem. A 800 watt, and I know that's giving me power. Electric drill is used for 20 seconds. And that's giving me a time, how much work was done. Alright, so power equals work divided by T. When I plug this in, my power in this case is 800 equals my work is my unknown. My time is 20. When I get to this point, I want to multiply both sides by 20. And that would give me a work of 1600 watts. Or excuse me, since I'm looking at work, that's going to be joules. It's also, remember that for work to be done, something has to move a distance. If it's just being held or if it's nothing moving, no work is done and no power would be done. Okay, my next problem, a box is pushed across the floor a distance of 10 meters with a force of 30 newtons in 10 seconds. How much work was done? Well, it's telling you the problem. It's being pushed a distance of 10 meters, so that's distance. 30 newtons is a force. 10 seconds is a time. Work, in this case, since it gives me the force, I'm just going to use the equation F times D. So work would equal 30 times 10 would be 300, and then the units for work are joules. And then I want to solve for the power. Well, power, since I found work, power is going to be my work divided by time. So I've calculated my work to be 300 divided by my time, which was 10 seconds. And when I divide that, my answer would be 30 watts. And then our last example problem, a 20 Newton object. So it's giving me a force here. It's giving me what Fg is. It's giving me the weight. It's giving me the force of gravity. It's lifted 2.5 meters, so that's a distance. In 2.00 seconds, that's a time. At a constant velocity, but it doesn't give me the velocity, so I can't use that equation, P equals Fb. So I have to calculate the power output. Power is equal to work divided by time. Alright, so it doesn't give me a work, so I'm about to use an equation for work. I know work is equal to mgh, but it's also equal to fd, and I'm given a force and I'm given a distance, so I'm going to plug fd in for work. So that becomes this equation. So then my power is equal to force, which was 20, times d, which is 2.5, divided by 2.00. So that would give me a power of 25 watts. So as a review, so far, work is equal to force times distance. Something's got to move though. No distance, work equals 0. Work, if you're given mass instead of a force, work would be equal to mgh. Height and distance, same thing. You'd have to multiply your mass times 9.8. And then if we have power, it's equal to work divided by time. And we can use a few equations. If we're not given work and we're given other information, we can use mgh over t, just plugging in mgh here for work. Or we could plug in, if we're given force times distance divided by time.